because of the fact that this is a 3 by 3, you might want to use your calculator for this, but you first have to identify your A matrix. So your A matrix, the first row, you have your X, Y, and Z, so it would be 3, -2, 5. The second row, you have 5 for X, 4 for Y, and 0 for Z. Because remember, each of these columns corresponds to those coefficients. So it would be 5, 4, 0. And then for the third one, you'd have 1, -2, -5. And then your constant vector, 21, 37, and 5. So again, this is your matrix A. Matrix B is going to be the constant vector. Now I put the B right next to it just because we could solve this using Gaussian elimination. So what we could do is we could set it up and use Gaussian elimination. An equivalent way of doing this is to take A inverse and multiply it by the column vector B. So in the previous section we did Gaussian elimination. Here we're going to use our calculator to do the A inverse multiplied by B. So first thing we would do is we would go to our second matrix, go over to edit, and edit matrix A as a 3 by 3 matrix. So you'd have 3, -2, 5, 5, 4, 0, 1, -2, -5. So we're not putting in the B vector, this is just our A. We hit second quit, then go second matrix, identify matrix A, and then our inverse. Now, you could calculate the inverse, but really what we want to do is multiply that by our matrix B, our column vector B. So what we're going to do is we're going to go second matrix, over to edit, cursor down to matrix B, hit enter, and matrix B is going to be a 3 row by 1 column vector. And so this is going to be 21, 37, and 5. So that matrix B is what we're going to put into our computing window here. So we'll do second matrix, and then we go down to number 2, beam, and then hit enter, and that calculates your solution vector. So this tells you that the solution vector x, y, z is equal to 7.5 and 0.2. Okay, so that solution vector would be written as 7.5 and 0.2.